Hey guys, welcome to the shop. This is part 2 of me and my wife Elizabeth's work on the Greener No. 3 Arbor Press. So in this video we're going to be making the handle for the press, which turns out really nice. I really like the way it turned out. And we're going to be making the press plate, yes. I make the handle, then together we make the press plate out of a big piece of A2. And we use the K&T mill. So it was a lot of fun. So I hope you enjoy. So I'm over here in the lathe and I'm doing some hard turning. And what I'm working on is the handle for the Greener No. 3 Arbor Press. I wanted a handle that would be strong, last a lifetime. I didn't want to use a piece of pipe. Everything I had around here was either too big or too small to use for a handle. But I did find a perfect candidate, at least in my opinion, and that is the CV axle or drive shaft out of the front wheel drive car. These are notoriously hard, so I had to go to a ceramic insert. Well, that's what I started with. Just a Sandvik CNGA 650, I believe. Yeah, CNGA 650. It's working really well. I don't do a whole lot of hard turning, so this is just fun for me, and it should work out really well. You won't break this handle. You shouldn't. Alright, so here's a look at the inserts. You get used to the weight of a carbide insert, and when you pick up one of these, it's a little confusing because they're so light. But doing a great job. These are, four-sided, so you get a lot of work out of an insert. A ceramic insert of this size. And all we're doing is taking light cuts. We're not trying to dig into this 10 to 20 thousandths at a time. And I just need to work down to this size here, which is a little over 900 thousandths. So a lot of unsupported shaft out here in the center, so I'm having to run my dampening system on the top of it just to keep it from getting harmonic. You'll see. But the chips come off really neat. They come off, well, they're not chips, they're strings, but they come off blue, just like a really light blue. So yeah, really neat, and quite a bit of sparks. So this is definitely some hard stuff. Let's get this turned down to size. We're almost there. We're just going slow. We're not in a hurry. Alright, so I just want to check for taper, just for my own sanity. Not that it matters on this piece, but I'm interested. And I'm going to check to see how much deflection I get in the middle too, because I know this is bowing, or the cutting pressure is pushing this bar away, at least some. We'll get an idea. So here at the chuck end, we are 922 and 4 or 5 tenths. We're close. And at the live center end, 923. So half thou between, what is that? Check this, see. It's about, a little over a foot, 13 inches almost. Check in the center. Should be bigger in the center. At least a little, I would think. Yeah. 923 and about 7 tenths. Yeah, 923, 924. Yeah, so yeah, pushing away. It doesn't make any difference on this part, but nice to know. So I need to just run this down to 900. That's it. So I'm drilling out the back of this Arbor Press handle, which of course was a drive axle. It's fairly soft on the inside, hard on the outside. I guess that kind of makes sense if it's an axle. You want it to be tough and flexible. So that's good. So I can drill this out and then tap a hole in it. I got to make something where this handle doesn't just slide all the way through the press the pinion. Alright, so that's pretty much complete, I think. Looks pretty good. And I think that I may just leave it as is. I'm not sure. I still want to think on that. It's just splined, you know, it's the end of an axle. So made a little end cap so it can't slide through the pinion, and it's got a raised area here, so that'll capture it. So it looks pretty good, I think. And you probably will not break that, I would not think, being a drive axle. So there you go. Let's move on to the next part. Alright, so for our press plate, we're going to be using this big piece of A2, and we first need to make sure that it's parallel. For this side, you know, if it's not, we've got to put it in the lathe. We don't want our press plate to be crooked, right? And that sets on the press. So we need to stone one side, set it on the plate, and then check to see if it's parallel. So this side's got a lathe knot on it. And this is a, I don't know, looks like a ground surface, but go ahead and stone that with a precision stone, really good, hard. Just to knock it off any little high spots. That's good, sounds good. Now take this and wipe it off. Wipe off this plate, we'll set it on the plate and we'll check it real quick.
This down?
Set this side down. Slide it on there. Alright, so now we'll get set up on the indicator and check it. Touch it in 0. This is a tense indicator, so it's super sensitive. So just, I mean, let's see how we get. I mean, that's pretty flat on the plate. So just rotate it, and let's see what we get. Wow, that's really good. Slide it out to the edge. Try just all the way. That's good.
Right there.
Yeah. So it's definitely high in this. I won't let it come off. So.
Oh, I'm not forgetting.
It's alright. So, I mean, it's within a couple thou. It's great for a press plate. I mean, it ain't got to be perfect. So, no work there. That's good. Alright, so I got some amazing viewer mail that I want to actually use to find the center of this. It's got a divot in it that probably is the center, but I want to check it to make sure. And I got a really neat story that I want to tell you really quick. So, Adam Booth came up, A-Bomb 79's his channel, for the meet and greet that we done in Lexington, Kentucky not long ago. This is just strange the way that this worked out. Anyway, A-Bomb constantly goes to these flea markets and stuff looking for cheap tools and stuff, or tools that he doesn't have at a bargain price. Well, he stops at one on his way home after the meet and greet, and he runs into a gentleman named Ronald Notch. Well, Ronald has a tool booth, and at the time that Adam Booth was in there looking at Ronald's tools, Ronald was getting a viewer mail package together for me. So I really can't believe the odds of that. Adam Booth actually sent me a picture of him and Ronald together with some of these tools in hand that he sent. And, you know, all I can say is thank you. It's some of the best viewer mail that I've ever received or I've ever seen anyone receive. So I'm extremely grateful for it. So thank you, Ronald. And, you know, he sent me a complete Starrett in the box protractor set. The protractor head, the square, and the center finder, and a brand new rule, along with some other stuff that I'll share with you later. And it is. So I'm happy that that divot's center. I mean, I'm pretty sure that it was anyway, but being that it was turned in a lathe, that's good enough. So we need to center punch this. We're not going to go crazy, you know, measure and accurate. I'm just going to center punch it, and then we'll take this over to the K&T and start working on it. Start out like this. Get it as close. This is a very important step. So as close to on the center as you can. And check it again. Make sure. I don't know that was good. And just stand it up on center, and then push straight down with both hands. Okay, how's that look?
Pretty good.
Let me see. Yeah. Alright, so I've got a piece of 1018 in here, and I'm just making some washers for my setup here. I don't have any large, thick washers to help with spreading the load out on my clamps on the K&T. So I'm just making a couple real quick. So before we start cutting, just a quick look at the setup. And what we're going to be doing is cutting all the way through in one pass. We're going to be running an 1.5 inch roughing end mill on the inside. So we'll cut 2 inches in, when we'll lower the table, come to the outside here, switch end mills to 1.25 inches, and cut 2 inches in on this side. And I'm going to be running the Noga Mini Cool. So this should work. So let's get started. Turn it off. There's one side. That end mill held up good.
So you're going to push this back and come to the side now?
No, we're going to lower the work. Come to the other side. We're going to change end mills. We're in the center line right now.
Yeah.
We're on the center line. So table and everything's locked. We'll just lower it, move to the other side, change our end mill, and do the same thing on the other side. So man, them chips, look how blue they are. That was, in my opinion, right on the edge of a little too hot. So it worked out. That was 3/4 of an inch, 3/4 of an inch per minute, and what was that? 202 RPM. So finish is fine. This is a press plate. Let's go to the other side. Brush some of them chips away. Brush them away from down there too, yeah. We're going to cut up to that line, so that's when we need to shut her down. Go. Good job.
Thank you.
Yeah. Pull it easy. Yeah. There you go. Come on down. Alright, that's good. Alright, now turn it off. We got to get set up to drill and ream. Nope. Turn it off. Good job, love. Alright, so while you weren't looking, I made an end cap for this ram. It actually looks like it was designed for some sort of, end piece. It's got a 3/8/16 threaded hole in there and a recess in the center. And it's kind of mashed up a little bit around the outside edge. So I think, that it was designed for some sort of soft end cap or hard end cap, depending on the needs of the person who has the press. So I designed this, didn't design it, I guess I did. I made it out of 305 stainless. So really it probably should be out of, a hardened steel because it'll divot otherwise, but you get the idea. For now that's fine. And should protect the end of the ram. Makes us lose just a slight bit of travel, but not enough to worry about. I'd much rather protect the end of the ram. It just screws up on there tight. You can make it out of copper, brass, anything. Yeah, I think that's pretty nice. Whether we keep it or not, who knows? But for now, I think that'll do. All right, so we got an obvious difference in our color of chips. Smaller end mill to sell in the second cut. Same spindle speed, same end feed, but smaller or lower surface feet per minute and less metal removal. So you can see how blue those chips are versus these. And we're just running the Noga Mini Cool with flood coolant. I mean, you could run much faster than what we was doing here all day long, I'm sure, with these roughers. They're really, amazing end mills. If you've never run one, you should get a couple because they cut like crazy. Stupid mosquito. We're going to need a drill and ream for our 5/16 pin, the pin that this pivots on, rotates. Okay, so I need to pick back up on my center punch here, and to do that I'm going to be using this coaxial indicator. This is one of the first precision instruments I ever bought, along with the vertical mill in there. This is a Char's brand. It's been perfectly reliable, although I don't use it all that often. A lot of times I use an indicol and an indicator for a lot of things, but picking up on a center punch, these are pretty good. Of course, I'd like a Blake. They're so nice, but nothing wrong with this one either. So let's get set up here and dial in center, and then drill and ream this hole. Hold that, Elizabeth. Just quite a bit off. Let us move until I get the least amount of movement in one axis, and then move the other till it moves less, and then back and forth. And I'd say that's it. So good enough. Sometimes it takes a second. Happy that's on center. And start bringing it up until you get halfway up the slope on that center ring. You're alright, go faster. Just go. You're alright. center drill. Now turn it off. Good job. Alright, so we're going to try to power drill this. How wise it is, I don't know, but we're going to try it anyway. So it's 19/64 drill. That'll leave basically 10% for our reamer to take out, our 5/16 reamer. We're going to be reaming it actually 1,000 below the 311.5 for our reamer size, using the indicator stand here to determine our depth. We're going to drill it 1 inch deep, and then we'll just, for safety reasons, only ream 3/4 of an inch deep. It doesn't make any difference. I just don't want to go all the way through. So let's try this and see if we can not break this drill off in this piece of A2. Pretty well. A little slow on our feed, but went well. Alright, so now we're going to ream it same way, just a lot slower. And we're not going to the bottom, of course. We've got to leave room for chips and stuff. Good enough. And we'll see how the pin fits. Whether that works or not. Not ideal, I know. It'll be alright. Check our pin fit. This was 1,000th under, so I mean, should be good. You know, it's close enough for what we're doing, so we'll press that in. That's pretty much done. Just deburr the sharp edge, but just lightly. That's it, you know, take them off. That's it. Get your prize. Press the pin in it and try it. You want to do the honors of its first press job, pressing the pin in? Just press it in till it stops. Pull off. Got it? That's it?
Yep.
Good enough.
How's it going?
That's it. That's all we need. There we go. Press play.
Cool.
Perfect. And we can adapt it as we need to.
Yeah.
Alright, so what do you think?
It turned out nice.
Turned out nice. I agree. Not finished completely, but you know, still, it is 100 times better than what it was. It was definitely rough. But now we got a nice functional handle, press plate, got a piece on the end of the ram there to protect it, and you know, other than a few odds and ends, like maybe a brass skirt here to support the handle. You know, I don't know. And it also needs a complete base, which I don't know exactly what I'm going to do yet, but we'll see. It's kind of got a special foot here. Let me bring you in and show you, how this thing's actually made on the bottom. It's kind of weird. Let me see, we've got a V-groove here and a recess. So I was told that this thing could optionally mount to, or could potentially mount to some lathes, which kind of makes sense with a V-groove. I'm not for sure, but I know that they sold a factory stand for this that had this incorporated into it, the shape of the bottom. So I'm gonna have to come up with some way to adapt that to something shop made. So we'll see how that goes, but that'll be down the road. But, so far so good. Alright guys, that's it for this week. I think as far as the press itself, it's pretty much done. Still got a stand to build, and we'll see. If she wants to take part in part 3, we'll maybe...
You want me to.
I do. Maybe we'll get you doing some welding. I don't know. We'll see. But that's it. So, thanks for watching, guys. Really appreciate it, or we really appreciate it. Huge thanks to my patrons, viewers, subscribers, all the guys who sent something into the channel. And that's it. So, thanks for watching, guys, and we'll see you next time.